Hello everyone, we are Group Radiation. I am Ryan Balindong, this is Bon Yuval, and this guy is John Derbare. Today we are going to be presenting our work about radiation. So first of all, what is radiation? Is it safe? How does it work? Don't worry, you will soon get your answers as we proceed in this video. Radiation is a flow of atomic and subatomic particles and of waves, such as those that characterize heat rays, light rays, and X-rays. Radiation is natural and found everywhere. It comes from outer space, the air we breathe, and the earth we breathe. Even in our bodies, naturally occurring radioactive elements in our bones irradiate us on average 5,000 times per second. Sleeping next to someone gives us much higher radiation dose than living close to a nuclear power station, both of which are harmless. What is radiation? Radiation is the energy in motion either at speeds equal to the speed of light, in free space approximately 3 times 10 raised to 10 centimeters per second. Although there are many types of radiation, me and my group mates would be explaining only 4 of them.
Alpha radiation is a heavy, very short-range particle and is actually an ejected helium nucleus. Many of the naturally occurring radioactive materials in the Earth, like uranium and thorium, emit alpha particles. An example most people are familiar with is the radon in our homes. Beta radiation is a light short-range particle and it is actually an ejected electron. It's an electron that is not attached to an atom, triton, which is produced by cosmic radiation in the atmosphere and exists all around us. Emits beta radiation, carbon-14, using carbon dating of fossils and other artifacts.
Ultraviolet radiation is the fourth type of radiation in our project. It is a form of electromagnetic radiation which wavelength from 10 to 400 nanometers, shorter than that of visible light but longer than X-ray. This radiation is usually found in sunlight because sunlight radiates ultraviolet rays. Gamma and X radiation. Gamma radiation and X-rays are highly penetrating electromagnetic radiation. Unlike the other kinds of radiation, there is no mass or charge. The amount of energy can range from very low, like in dental X-rays, to the very high levels seen in irradiators used to sterilize medical equipment. Although there are a few types of radiations that we showed and tried to explain in this video, there's one particular radiation that could harm us, especially the teenagers, and that is the blue light radiation. Based on allaboutvision.com, blue light radiation is a visible light spectrum that is comprised of electromagnetic radiation, and its wavelengths can range from 380 nanometers on the blue end of the spectrum to about 700 nanometers on the red end.
The advantages of radiations are capable of passing deep inside the body and damage cells on their travels, but as well as causing cancer, they can be used to kill off cancer cells and even cure people from this illness. The disadvantages of radiation is it collides with molecules in the air or in your body. It throws out of them electrons. If this happens in our body, the cells may die or they may undergo a change called mutation. The result is called radiation sickness. A large dose of radiation.
We therefore conclude that there are advantages and disadvantages of radiation. So we must limit or avoid the use of radiation for the sake of our health.